Morning. It's the unknown mechanic back again with another how-to video. We're trying to help out, the shop owner who doesn't always have the technicians that are up to par, the homeowner, do-it-yourselfer who likes to, learn and educate themselves on the right way and the wrong way of doing these kind of repairs. If you're just looking for a quick fix, 5-minute, solution for one individual problem, this is probably the wrong channel. I like to go into detail and put forth, trivia and historical information and methods that have been perfected over decades of working on this stuff. So today we're working on a vintage Husqvarna Model 65 chainsaw, and it belongs to Hiram Humbucker. And it says hard to start, won't start, repair starter. Now, the customer probably broke the starter trying to get this to start, and it's obviously not going to start. It's going to need some kind of repair. And, I've had a lot of crappy mechanics that have worked for me. We had Gomer and Sniffles and Dingus and Scratch. And our newest mechanic, Speedy. He's aspiring to be a top mechanic, and he's got a little ways to go. He tends to rush into things and get ahead of himself and then get into trouble, and that's what's happened with this. He repaired the starter. He actually did it incorrectly. I'm going to need to redo that, and I'll show you that part after I address the real issue. But then he, took it outside and tried to start it and wouldn't start, obviously. So I brought it back in, and he really likes to overhaul carburetors. He jumps right into the carburetor, and he likes the sonic cleaner a lot. And he'll take a carburetor that is caked with sawdust and dirt and do very little disassembly and just throw it in the sonic cleaner and let it brew for 20 or 30 minutes, and then take it out, and he thinks that just like magic, the sonic cleaner will magically make the carburetor work again. And that's not how it works. I personally think that the sonic cleaner is better suited for 4-cycle lawn and garden carburetors rather than these diaphragm all-position 2-stroke carburetors used on handheld equipment. And one of the problems that he does get himself into, he doesn't change the cleaning solution often enough, and the cleaning solution ends up turning into sewage. And he can actually, you can actually contaminate a clean carburetor with dirty sonic cleaning solution. And he's actually had a couple comebacks because of that, where he'll sonically clean, I think these were both blowers, if I recall, and then they come back right away with leaking needles and a flooding condition. And so, he's not removing the secondary filter and fully disassembling these and using, clean solution. So he's actually putting dirt into the carburetors. Actually, we've even caught him running loads of laundry in the sonic cleaner. Found a couple of loads in there. So, sonic cleaner has its place, but it's got to be used properly. So after he overhauled the carburetor, he took it outside and pulled it, 100 times for like 15 minutes, and it won't start. So he gave up on it, and now it drops in my lap. That's what happens. Everybody makes a mess, and then I have to come along after them and clean it up. So I did some of the troubleshooting that he skipped. And, I did the compression test, and I found that the compression was 120, and that's very low. So I told him to take the top end off, and we'll do an inspection. So he took the top end off, and what I found was a lot of scoring on the piston. I'm moving this in, and I've seen worse. That is the intake side. The exhaust side is a little worse. And even in the under the crown here, one of the thrust bearing surfaces for the top end of the rod is a little worn. And also the ring's worn. I'm going to show you that in a moment. Cylinder, let's take a look here. You can see a lot of vertical scratches. This is the intake side. It's a little bit better than the exhaust side. See, that's even more scratched. Now there is no aluminum transfer, so that's good. I've seen a lot worse. Now, unfortunately, he's already gotten too deep into this machine. He has installed some new old stock, no longer available parts in it. These bar studs, he replaced those. One of the bar studs, was completely stripped, and the other one was stretched. And I had 6 of those left, so he used 2 of them here. And he also changed the spike mounting hardware. We had the original flathead 5mm slotted spike mounting screws and lock nuts to mount the inside spike correctly. There was a vent extension tube that we put on there that was missing, and a spring. There was a broken spring in the rewind starter, and I'm going to redo that later. And so, he got pretty far into it and came up with a dud. So rather than strip all the parts back off of it and put them in stock and give the customer the bad news that it's unrepairable, I thought that I might be able to salvage this job and get it to run and save it. So I called the customer, talked to Hiram, and told him that this top end is no longer available. We probably sold the last one a few decades ago, and the piston's not available. The only thing that I had left in stock was 1 piston ring, and so I told him we would give it a try and see if we can get this to go. And so he gave us an approval. He doesn't want to spend lots of money on it. A top end, even if it was available, that would be quite expensive. So, but he's willing to chance and put a ring in it and see if it'll work. So that's what we're going to do. If you have aluminum transfer on one of these cylinders, on a steel or Husqvarna, one of the European saws, the surface of the cylinder is so hard that usually when the aluminum transfers, it will not dig a trench in the surface of the cylinder. You can take muriatic acid in an eyedropper and dissolve the aluminum transfer, and then after that's gone, then you can use a hone and hone the cylinder, and then you can use a new piston and a new ring. In this case, we're gonna reuse. We have no choice. We have to reuse the old piston. We're gonna put a new ring in it. So in looking at this, I'm going to bring this in for a close-up of the ring and take some measurements. The Model 65 is a single ring. Now, its big brother saw back in the day was a Model 77. And the Model 77 used 2 piston rings in addition to being 77 cc's instead of 65. So 77 was actually a better saw. Now what I'm going to do is I'm going to see if I can show you a comparison. I'll put the old ring right on top of the new ring. And you can see, I hope you can see that the old ring in certain areas is noticeably thinner in width. So I'm going to actually measure that with a caliper. Turn my caliper on here. And we'll take a few measurements. And that's 72, 73, 65, 73, and 75. So it varies in width as you go around, the exhaust side being the thinnest. Now comparing that to a new ring, got 78, 78, 79, 79, and 79. So this ring is very, very uniform as you go around and measure it. And it's brand new, and that's, you know, what they start out when they're new. Even this ring is it's limp when you compare it to a new ring. This is a lot stiffer. So this ring, not even Viagra is going to save this ring. It's just too limp. What I'm going to do is, since there's no aluminum transfer, I'm not going to do the acid. I am going to go right to the hone. And I've got quite a few of these. These are made by Brush Research Manufacturing. And I've got quite a range of sizes to cover many chainsaws. Some of them I haven't even used. This one I've used. That one I've used. This one is still sealed. I've got this one. I picked this one out. These are called flex hones. And this one is a 51 millimeter or a 2-inch. And the Model 65, the bore is 48 millimeters. So 51 millimeters, that's going to, see, it fits snug in there. And that's going to be applying, 3 millimeters worth of tension against the stones to break those vertical scratches off the surface of that cylinder. So also I'm going to bring you in and show you a close-up of the bottom end of the engine here while this is apart. I've looked at this, and you know, this bottom end, that is one beefy crankshaft. They don't make them like that anymore, and the rod is very stout. The pistons are kind of heavy compared to modern saws. So the bottom end is in excellent condition. I'm not worried about the main bearings or the rod bearing. There's no blue coloring on the bottom end of the rod or even the top end of the rod where it would indicate that this overheated. So I'm satisfied with the bottom of the motor. Okay, so I'm going to pause the camera and I'm going to set up for the honing. We're going to try to produce a like a 60-degree cross-hatch crisscross pattern on the surface of the cylinder and take those vertical scratches out. I'll set that up and be right back. All right, back again. I've got my setup ready to go. I do actually have the BRM Flex Hone oil. If you don't have this, you can use automatic transmission fluid, also works well. I've oiled the cylinder. I'm going to oil the hone. All right, that's pretty good. And probably going to go for a couple of minutes in there. Got the drill set on first gear. Turn this to the drill position. Okay. Get a flashlight. Here. Okay, hope you can see that. The next step is thorough cleaning. You can't just wipe the cylinder out with a rag. It has to be cleaned with soap and hot water. That's the only thing that's going to remove all of the grit. So I'm going to pause the camera and I'm going to go clean it thoroughly. I'll be back. Okay, I'm back after cleaning the cylinder in very, very hot water and soap. And I'm going to bring this in and you can take a look and see. Hopefully you can see that. Looking for that crosshatch pattern. And we'll go over to the exhaust side. Yep, and so most of the vertical scratches are gone. And Yeah, that looks pretty good. Okay. So we're going to do a quick assembly. I have treated this gasket was stuck on there really tight, so I decided not to remove it and use a new one. I do have a new one in stock, but it's the last one. And this one, I know it's going to seal on the bottom, and what I've used a brush and some gasket, spray gasket, and brushed the spray gasket on the upper surface of the gasket so it will seal on the bottom of the cylinder. And you have to allow that to become tacky. And before I button this up, I'm going to point out a couple of things. There is an impulse hole right there, and that is how the pulse passage is routed through the insulator into this crossover passage, and then through the gasket into the carburetor and the fuel pump. So we definitely don't want to block off that pulse hole. The gasket is positioned correctly. There's actually 4 cutouts, so no matter which way you put that gasket on, you're not going to block off that pulse hole. The other thing I want to show you is, while the saw is apart, okay, there is a line scribed into the cylinder, crankcase rather, right there, and there's a corresponding timing mark on the flywheel. And these old school saws, there were points in condenser under the flywheel, and the most accurate way to gap the points is by using the timing marks rather than just taking a feeler gauge and setting it for a specification. That'll get you in the ballpark. But if you go the extra mile and adjust the points so that they just begin to open when the timing marks line up, you'll have a saw that just runs perfect. So I wanted to point that out before I buttoned up the cylinder. So my assembly lube is straight 2-cycle oil. I'm going to oil the big end bearing, and I'm going to oil the wrist pin bearing, and oil up the wrist pin, and the piston. The piston has an arrow on it, and that arrow is to point towards the exhaust port. Now, the other thing you want to do when you're installing the circlips is the opened end of the circlip. You want that at either 12 o'clock or 6 o'clock. If you put the open end of the circlip at either 3 o'clock or 9 o'clock, there is a small possibility that under very, very high RPM, that circlip will flex and flex and flex, and then it can jump out and destroy the motor. So that's possible. It can happen. So you want to position the circlip with the opened end at 12 o'clock or 6 o'clock. So I'm going back on here, and I'm making sure that the arrow is pointing towards the exhaust. I've got my wrist pin bearing in there, and I've got my wrist pin oiled. And this is not a press fit, so it doesn't require a tool to push it in there. You just got to line it up. And hopefully it will go in. can see it easier if I turn it around. Oh yeah, I can get a better view. There it goes. Okay, a little bit tricky to line it up. It's all the way in there, seated on the circlip on the opposite side. You can start and just pop that ring in. And I'm going to just turn it around and swivel it to the 12 o'clock position. And then I've got to make sure I put the new ring in. That's the old one. And there is a pin, a retaining pin that prevents the ring from rotating. And so those half moon cutouts have got to be facing up. And there is the pin that prevents the piston ring from rotating in the bore. And there, and that ring is very free in that ring groove. And we are going to oil the cylinder, 2-cycle oil. And then I've got a piston support. This is going to help. I'm going to compress the ring. Go. All right, I am going to pause the camera because you don't need to see the nut and bolt operation. That's just going to waste a lot of time, and my videos are already too long. But I thought it was important to show, because if you make a mistake on these expensive engine parts and it blows up, then you've cost yourself a lot of money. So I'm going to stop the camera now, and I'm going to do the nut and bolt part. Okay, back again. We're ready to reassemble the starter the correct way. The way Speedy had it put together, this rope retainer, the rounded end, he had this inverted around the wrong way, and he had the square end butted up against the rope pocket. The round end is supposed to go against the rope pocket. Now, Husqvarna used to use these on this style starter because if you tie a knot and you omit this rope retainer, the end of the knot is going to protrude out, and it's going to interfere with the operation of the starter pawls. And the other reason is that the edges of this rope pocket hole where the rope goes through are very sharp. And if you omit the rope retainer and you just tie a knot, the pulley will cut the rope and it will fail. It'll fail right at the knot. So back in the old days when we used to sell these ropes, they came with the rope retainer already installed. But obviously they're no longer available, they're long gone. So what you have to do is you have to keep reusing the rope retainer and just put a rope in there. And the other thing that he did not do, since it was on backwards, is the hole in the end of the rope retainer is countersunk. And that allows for the rope to go in there, and you melt the end of the rope and you push it down into the counterboard hole, and it sort of flares the end of the rope out. So that's what I'm going to do. I am going to heat this up. And while it's hot, I'm going to pull it down in there. And now the flared end of the melted rope is in that countersunk bore. And the final retention method is a very small screw. You've got to run this screw in there. Okay, so the screw is in the rope retainer. Now you can pull the rope back and you seat this rope retainer down into the pocket. And it is a tight fit. So it's seated down in there, and it does not protrude higher than the surface of the pulley and interfere with the starter pawls. So next we want to install the starter spring, and he brought it in with a broken rewind spring, and luckily we had one left. A brand new old stock OEM Husqvarna 65 recoil spring. And these older style ones, they're pretty stiff and they're difficult to get in. And lots of people have different methods of winding these things up. I've seen some starter winding tools that are pretty scarce, but you can find them. Also, I've seen people try to drive a nail in a piece of wood and then wind them up with an electric drill, and that's for amateurs. A real pro, you don't need any tools to wind these things up. You just got to have some muscles in your fingers, and you just wind them up. And you need a pair of duckbill pliers when you get to the final stage. It's got to be wound up a little smaller than the hole. And once it's in there, it's going to unwind exert pressure outward. So, it's not going to fall out of there. It's only going to come out of there if I drop this, and then it would jump out. And I do like the way that it has a relieved coil. This is approximately in the right position. I'm going to be able to get that in no problem. A lot of springs, use different designs for their spring ends. This one's just got a simple hook, and over here it's got kind of the reverse European bend. And these are pretty reliable springs. A lot of other springs have more than one inner coil relieved. There will be 2 or 3 coils relieved in here in the center. And the way they work is, when you start pulling the rope out, one coil at a time progressively releases and it winds up. And then when you get to the end of the rope and the rope is being retracted, in turn it goes in reverse. Each coil in succession expands and fills this outer part one at a time. And so you don't want to be bending around with the springs and altering them to get them in. You leave them alone, you wind them up and you put them in. That's the way they work. So I need to align this with the hook and drop that in so it's going to hook on there. And one of the other mistakes that Speedy made was he used a very, very heavy high temperature grease on the spring. And it was way too sticky. And when you pull the rope all the way out, it didn't want to retract, or it retracted very slowly. You want to use a very light grease. This is 00. This is 0 grease. Or even better yet, a lightweight oil. And so I am going to be oiling the spring and greasing the post. Just you don't have to overdo it. And we're going to drop that in so that hooks. Got it first time. Now there is a nylon bushing in the center of this pulley, and I checked that, and it's not worn at all. It fits the starter post bushing very well. So at this point I am going to use a number 0 grease, and push that in there. Okay, and then there is a very heavy countersunk washer, putting the countersunk side up. And then this is a 6mm flathead Allen screw with dry adhesive already on the threads. So it's pre-Loctited. This is a special screw, that's what goes in there. And then the other end, you don't need to tension it at this point. Oh, I got my rope insert in there the wrong way. I'm going to flip that around. Go this way. Push that back in there. Okay, now it's the right way. Put a few turns on it. And then the other mistake that Speedy made was he just tied a standard knot. If you just tie a regular knot like such, it's probably going to be a little bit small and at risk of a pull through. There could be a pull through. So my favorite knot is the one that Steel uses. I use it on a lot of equipment. It's sort of a self-tightening knot, a knot of that variety. The harder you pull on the rope, the tighter this gets. The other advantage of this knot is that you can easily untie it. Okay, and that fits right down in the starter grip recess. And a lot of starters have a pre-tensioning notch, and I'm going to utilize that. Got to form a loop using the notch, and then you start pre-tensioning. Now, how do you know you have the right tension? Well, what you want to do is pull this all the way out and see if it bottoms on the rope. And after it bottoms on the rope, then you continue turning it. Okay, now there's nothing left. That is one turn too tight. So I am going to detension it one turn. Right there. Okay, so if I pull this all the way out and it bottoms on the rope, and I know that there's one additional turn of reserve spring left. And if you don't do that procedure, if you over tension the spring and you pull the rope all the way out and it bottoms on the spring before you run out of rope, you will break the spring. And if you under tension it, then you'll get a sluggish retraction of the rope, and you're not utilizing the full capacity of the spring. This is what you want. Now, the other mistake that Speedy made was he greased all of this starter pawl mechanism with the heavy, sticky grease. That's just going to attract dirt and gum up the whole works. I'm not going to degrease it at the moment. I'm going to just put the starter on here, and we're going to do a little bit of a compression test. See, now that I have a new piston ring and I have honed the cylinder, I'm very curious to see how much compression we have. Let's go with 3 screws for now, just for test purposes. I have my compression tester ready. Let's see what we got. Okay, now I got, remember I told you before that you could pull this thing 1,000 times and you could never get it to peak past 120. In one pull, I got 120. And then you can see that, 2 more pulls, I'm up to 150. And that is, that brand new piston ring has not even run. This engine has never run. So that brand new ring with all the tooling marks and the crosshatch pattern scratched into the cylinder surface, it's not going to produce full compression the first second. So this is already a dramatic improvement. And I'm going to pause the camera at this point, and we're going to resume assembling the saw. You don't need to see the nuts and bolts of that. Maybe I'll show the carburetor, a few things on the carburetor and a couple other things, but I'm going to pause at this time. Okay, back again, and we're going to revisit Speedy's carburetor job before I assume that everything's perfect and put it back on the saw. Always want to double check. First thing, everybody that does carburetor work has got to have a good pressure tester. This is an Echo. I like this one because it has a glass lens, and some of my other ones, Walbro one, the Tillotson one, it has a plastic lens, and if you spray carburetor cleaner all over the place and you get a drop of carburetor cleaner on your lens, it'll fog it up. So that's why I like this one, even though this one doesn't have PSI, it's metric, just in a bar scale. So I'm going to connect this up to the fuel inlet fitting, supply fitting. Let's see, pump it up to about 1.5 bar. And we have a very, very slow leak. Very slow leak. So it's not too bad. So this is a Tillotson HS123A, and in the event I need to kit it, overhaul it, I've already prepared and looked up the correct repair kit. Calls out for an RK23HS repair kit, which I've got. And I'm going to remove the metering side first. Okay, I see a problem right away. Two problems. So take this in. Okay, first problem is the metering lever. I think when Speedy was taking the metering diaphragm off to look in here, he didn't realize that it was a captive style with a forked metering lever, and he pulled up on it and bent the metering lever up. It is way too high. It's supposed to be flush with the floor of the metering chamber. That's the first problem. Second problem I see is the metering diaphragm. The umbrella frame is bent. Okay, that umbrella frame is supposed to be flat as a pancake. It's not supposed to have any potato chip curves or dents or anything in it. It's got to be flat. So that's a definite problem. At this point, I'm going to retest. Back up my pressure tester again. I'll pump this up. To about 10 pounds. test the needle by putting some fuel on there. And yeah, we've got a leak. Yeah, it's not supposed to be leaking like that. Oops, that's a problem. So I think I am going to go ahead and kit this. So to prep this for cleaning, we're going to thoroughly clean it. I'm going to remove the pump cover. It looks reasonably clean. Diaphragm's still soft. I've seen a lot harder ones, petrified ones. Now to get the secondary screen, this is the secondary fuel filter. There's always a primary filter that's inside the gas tank connected to the end of the pickup hose. Any dirt that makes it by the primary filter, and gets through the fuel pump, and it's going to hopefully get caught in the secondary filter, which is in all carburetors is very close to the inlet needle tip and seat to protect that. So that's very vulnerable. So they always put the filter as close as possible to the needle and seat. So I like to use a very sharp tool to go in here to pry the filter out. And there it comes, got it. There's a brand new one in the kit. I'm not going to reuse that. Now I'm also going to be removing the metering lever. There is a new metering lever in the kit. Okay, yeah, that's pretty bent at the other end as well. Bring that here. I don't know how well you can see that. But it is bent. Yeah, okay, it's bent at both ends. So I'm not going to reuse that. I'll use the new one. Not going to reuse this as the old one. This we're going to reuse. And then the metering lever spring, they do not supply that in the repair kit. And if it's not in perfect condition, you got to get a new one. That one looks like it's okay. Now, this style of HS carburetor, a lot of these carburetors, you need to be able to trace the fuel circuits. And this is an independent circuit carburetor. The low speed circuit picks up from this little hole down in here and is adjusted by the low speed needle. This one is marked H, one is marked L. And this Welsh plug covers up the idle circuit. The high speed circuit picks up its fuel through that hole in the floor in the metering chamber and is adjusted by the high speed needle. And these needles, I'm going to be removing those for cleaning. And I don't think you can mix them up because they are different sizes. The thread is different, so you can't interchange them by accident. But one of the things I'm going to be doing is I am going to be removing the high-speed Welch plug. I can tell that this style of carburetor, if I open the butterfly and look at the venturi, I do not see a high-speed nozzle protruding into the venturi. And that would indicate that this is an early style and it does not have a capsule style check valve for the high-speed circuit. What's under the Welch plug there is a screen, and that screen, when it gets wet with two-cycle fuel and the engine is idling, air cannot pass through backwards through the high-speed circuit and allow air to enter the metering chamber and lean out the engine when it's idling. It's a very primitive style of high-speed check valve. The more modern carburetors have a nozzle pressed in that has like a nylon ball or a fiber disc wafer, and that would check the air from going backwards through the high-speed circuit when the engine's idling and then allowing air to enter the metering chamber. So that screen seals through what's called capillary action. When it gets wet, low pressure air won't pass through it. So I'm going to be taking that Welch plug out, and one of the main reasons is that dirt can work its way into the carburetor and get into the high-speed circuit and plug up that screen. So I'm going to want to take that plug out. There's a new plug, a new Welch plug in the repair kit. So to get the plug out, you need to cave it in with a small punch. And got some punches here. And that was easy. Take a look. And it's kind of hard to see down in there, but it doesn't look too good. So I'm glad I took that out. Now I'm going to remove the high speed and the low speed needle. And I'm going to shut the camera off and do some cleaning. You don't need to see all the cleaning. So I got the carburetor quite disassembled to a pretty far state. And that's your cleaning state. You don't want to throw an assembled carburetor into the sonic cleaner or try to clean it together. You got to take it apart. Okay, going to do some cleaning and I'll be back. Okay, the carburetor is clean now, and I'm going to begin doing some reassembly. I wanted to show you a few things close up. So I'm having a hard time getting the camera to focus on that metering lever, but now you can get a good look at it, and you can see that the fork is bent. It contacts the needle compared to the new one. Now here is the screen that goes into the high-speed circuit and its retainer. On the left is the new one out of the kit. In the center is the old one, and on the right is the retainer. So, and then these are the needles. It's probably hard to see, but the old needle is on the left, the new needle is on the right. The old needle has a very subtle groove in the tip, and that could account for that small leak. Probably has high enough hours on it that it's starting to leak. So I wanted to demonstrate the capillary action. I'm going to get this. Let me put it in the stand here. It's not going to focus. Okay, I'll do this carefully. Okay, once the screen is wet, low pressure air will not flow through it, and that is the check valve feature in these primitive Tillotson carburetors. Like I said, the more modern ones have an actual capsule nozzle with either a nylon ball or a disc wafer. So I wanted to demonstrate that. I'm going to be putting this back into the carburetor. Goes down in there. Okay. You get a flashlight too. Okay. There it is. That's a new screen and an old retainer, and that is the high-speed check nozzle. Now I'm going to be putting the new Welch plug in it. Cover that back up. You have to put the domed side up. And then when you flatten it out, the plug will expand and seal. So I'm using a flat punch that's slightly larger than the diameter of the plug. And then you can see that the new plug is in there, and the domed part has been flattened, and the plug is expanded, and it's not going to come out of there. So that step is done. You know, the other thing I noticed is the Sonic Cleaner did not remove all the remnants of the old gasket. I'm going to want to be very careful in cleaning this pump cover to preserve these crush ribs, these ribs that surround all the chambers. That is called a crush rib. And that's what bites into the gasket and seals the gasket from any air or fuel migrating sideways through the gasket material. Usually the poor quality aftermarket repair kits, they leak like a sieve. And this crush rib is crucial in attaining an airtight seal. If you were to take a gasket scraper and aggressively damage the crush ribs, you're going to destroy it, and you'll need a new pump cover. These crush ribs are very, very important, very crucial. And that's true with all of these diaphragm two-stroke carburetors. So I am going to use a handheld wire brush. Let's see, I misplaced my brush. Oh no, here it is. Here we go. Okay, it's getting there. Okay, that's better. Okay, so you see that type of a cleaning method is very safe for the crush ribs that are cast into the pump cover. Do not want to destroy those. I always rebuild the pump side first, and another thing you want to do is you always rebuild wet, never dry. These gaskets seal much better when they are soaked in 2-cycle fuel. And the diaphragms, the check valves on the pump diaphragm, the metering diaphragm, all that seals much better, much more effective if it's soaked in fuel. So diaphragm on the pump side, the diaphragm goes on the body first. That way the two one-way check valves are lay flat valves. If you make a mistake and you put the gasket on the body first and then the diaphragm next, these check valves will not lay flat. They will be held above the carburetor body, and it's not going to work. So pump diaphragm on first. Then the gasket. And then the pump cover with crushed ribs preserved. We'll tighten the pump cover in a crisscross fashion. And as I am tightening these 4 screws, that crush rib cast into the pump cover is biting into that brand new gasket and forming the seal. Okay, now we are going to, oh, one thing I forgot to do, I did forget to put in the new fuel filter. Got ahead of myself, just like Speedy. Do not want to leave the secondary fuel filter out. So here's the brand new secondary filter. It sort of sits down into that recess. Use a small flat tipped punch, and it just presses right down in there. Good thing I caught that before I got really far ahead. So once again, I am going to tighten the screws in a crisscross pattern. Okay, so we're going to start. Okay, pump side is done. I always rebuild the pump side first, and you're going to see why in a moment. So we are going to be using the new needle, reusing the old spring, a new lever that is not bent. Okay, now we need to have a straight edge to determine if the metering lever is at the right height. Looks really good. I don't think I'm going to have to do any bending here. Turn it around the other way. So I'm checking the metering height. It's supposed to be level with the floor of the metering chamber. That looks good. So don't need to bend that up or bend that down. Now is when you do your pressure testing. You do not reassemble the rest of the carburetor and pressure test it and find out that it leaks, and then you have to come back to this point. I like to test it right here at this point. Fuel pump side fully done, metering side needle installed. And the needle does need to be wet. Okay, now we've got it pumped up to about 10 psi. And I'm going to bring the camera in again, and remember that it was bubbling before. Let's see. Very, very minimal, a lot less. So let's see. Much, much, much better. About 10 psi, and you see the needles holding steady and very few bubbles there. I think that's going to be good enough. It's better than the old needle. So now I'm going to install the metering side, and once again you rebuild wet. And I have checked this diaphragm. The umbrella frame on this one is flat as a pancake. And another thing I want to point out is all of the high quality OEM kits, made by Walbro or Zama or Tillotson compared to aftermarket kits, one of the key things in a metering diaphragm, aside from this umbrella tent, is the convolution. And the convolution is this bubbled area, sort of a donut bubble. And if that is not perfectly formed, the carburetor is not going to meter accurately. High quality OEM kits, this donut shaped bubble, which is called a convolution, is critical. So before I put this in there, I want to mention that. And I am going to carefully hook the captive fork of the metering lever onto the rivet. Got it. It's 90 degrees, 180 degrees out of position. Let's start over. There it is. So I'm sure that the fork of the metering lever is hooked into the rivet of the diaphragm. And I'm going to put the metering cover on. And then the last thing will be reinstalling the high speed and low speed needles. Once again, I'm using a crisscross pattern. And I believe the preset on these high and low needles is 1 turn each. Start with the low. You'll run it in until it lightly seats. If you force it into the seat, you can damage the carburetor. Okay, there, lightly seat, back out 1 turn. We'll be fine-tuning it after the saw starts and runs. Okay, lightly seat, 1/2, 1 turn. Okay, so carburetor's all back together. One thing I do want to mention is the generic flange mounting gaskets that Tillotson supplies with their repair kits. One's got a larger venturi size, and the other one's smaller venturi size for the 2 most common HS carburetors. I guess this one would be the small bore. See if it's this one is, it's bigger than the bore of the carburetor. I never use these, and the reason is that there's an impulse passage that's curved, and that curve exceeds it goes out from under the gasket. And if you were to use the Tillotson gasket on this intake flange on the Husqvarna, as opposed to this wide gasket, you would expose the pulse in the insulator to a leak. And then you will get no positive and negative pulse being directed into that hole, driving the fuel pump. And no fuel pump, saw won't run. So I never use these. They're not wide enough. See the difference? So, you always got to be aware of that. So now we are at a nut and bolt operation, and I'm going to shorten the video. I'm going to edit that out. So I'm going to stop. Well, actually, I do have a couple more things I can show you. There is a foam seal that runs around the air filter cover. And lo and behold, I had one left in stock, new old stock, no longer available. And when I pulled this out, I thought it was going to be rotten and crumble into dust like a mummy. But apparently it's still good. And so that's a good find there. And the other thing I ran across was his inner and outer bar plates trashed. And when the bar plates are bad like that, you can get the chain riding over and damaging the sprocket cover and also the crankcase. So in stock, what I had left, I had one OEM original inner bar plate, but I was out of the outside bar plate. But I do have a substitute. Rotary made a substitute. It's part number 4925, and it's a set of one inner and one outer. And this also is now obsolete. But since I have it, I'm going to use it. And that's going to protect the crankcase and the sprocket cover. Let's see. And then there was one other part that I had here. The throttle linkage has a very tiny hairpin clip, and I had 6 of those left in stock. So I've got a brand new genuine factory Husqvarna throttle linkage clip. So I'm not going to put this stuff on until I get the saw to run. The saw runs like 99.9% sure it's going to run. If Speedy was working on this, no, he couldn't get it to run. But if I work on it, it's going to run. So, but I'm going to get it to run first, and then I'm going to put the remaining parts back on, and it'll be sort of restored. Even it's very, very hard to find parts for a saw of this vintage, but we're going to be able to get it complete. So I'll be back after the nuts and bolts. Okay, we're just getting ready for a test run. Just a couple things I want to point out that's kind of unique to this saw before I run it. This is one of the first professional Husqvarna saws to have a cross-drilled crankshaft, and that allows you to use this needle nose bar nose greaser here to grease the clutch bearing without removing the sprocket. And I did notice a couple things. His bar and chain are an issue. He's got 3 broken off cutters in a row here, and the rest of the cutters are tiny, so this chain is trash. And more importantly, this is a Homelight bar, not a Husqvarna bar. And the motor mount is a Homelight motor mount. And that's going to be a big issue because the oiler hole in the Homelight bar mount does not match the oiler output on the Husqvarna bar pad. So I'm going to bring that to his attention that he's not going to be able to use this bar, and he definitely needs a new chain. I was able to find, even though this saw is so old, I did find an ancient technical specification chart that does have the 65 and the 77. It's supposed to idle at 2200, and for a new engine, maximum no load RPM is 11,000. After it's broken in, it can be 11.5. And did not find a service manual for this saw. I've got a number of old service manuals, but not for the 65 and the 77. So I'm going to be using a tachometer and adjusting to get those specs. One other thing I ran across that's kind of rare is I do have the proper spark arrestor removing tool. It's a spanner wrench that fits the spark arrestor here, so I don't have to use any hammers and chisels or anything to remove the spark arrestor, clean it, and put it back. That's a special tool that's rare. So I'm not going to put the rest of the parts on until after I run it. I want to make sure that it runs first. So I'm going to shut the camera off. We're going to move outside. Okay, back in the shop after a test run, actually 2 test runs, and I'm just cleaning up a few last details, one of which is this saw has an oil filter access plug, and so I removed that plug and cleaned the oil pump pickup filter. And I added bar and chain oil on the second test run and confirmed that the oil pump is operating. So that is done. And I have also glued the new old stock, no longer available air filter cover seal in place. Used this stuff, and it is drying, and so that's the last detail. And then the last thing I'm going to do is another compression test, and I want to see if the compression has risen any. So we're going to try it. The saw has about 5 minutes on it. Okay, one pull we're at 125. Okay, now we're at 161 on the third pull. So the ring has begun to seat. Now, after the saw runs about 1 to 2 tanks of fuel, it'll probably go up a little bit more. So that is the completion of the Husqvarna 65 vintage chainsaw repair. We're going to return it to the customer. If you like the video, make sure that you subscribe, and also it helps me when you leave comments. I really appreciate that. Thanks.